Hello everyone and welcome to another AtMaths tutorial video. Now I'll be discussing Form 4 Additional Mathematics, Chapter 9 Differentiation, Long Question Example 2. Let me read the question now. The gradient of the curve y equals to hx plus k over x square at the point -1, -5 is -1. Find the value of h and of k. For the question part B, find the coordinates of the points on the curve y equals to 2x minus 4 to the power of 3 such that the tangents at these points are perpendicular to the straight line 6y plus x equals to 1. Alright, before that, if you haven't subscribed to the channel, please subscribe to the channel and hit the bell icon for more upcoming mathematics tutorial videos in the future. Okay, without further delay, let's go to the solution now. We're going to start to look from the question A followed by the question part B. Alright guys, one thing you should know, whenever you're dealing with two variables, that means you should know that you are forming a simultaneous equation which involves two equations over here. Okay, that's what we're going to look for the question part A. So we're going to form a simultaneous equation. Okay, let us have a look now. So to start off, we're going to rewrite the whole equation over here. Y equals to hx plus k over x square. Since the question already gave us the coordinate -1, -5, so we're going to substitute the point -1, -5 into the y. So from here, we substitute in. So from here you get -5 equals to h in the bracket -1 plus with k divided by -1 square. So you times in, you get -5 equals to -h plus k. So from here you get your first equation. -h plus k equals to -5. So this is your first equation over here. Okay, proceed to the next step. So for the next step is, what we're going to do is, we're going to differentiate y with respect to x. Okay. So what we do in this step, we bring the 1 over x square, we change it into the x to the power of -2. So where you get your hx plus k, x to the power of -2 over here. Okay, the reason why I changed to this form, so that it's easier to us to conduct the differentiation. Okay, proceed to the next step. So from here we differentiate our y, we get our dy dx equals to h minus 2kx to the power of -3. Okay, proceed to the next step. So from here you get your dy dx equals to h minus 2k over x to the power of 3. We change back this form into the fraction form over here. The negative power to the fraction form. Okay, so once you get the dy dx, so what we're going to do now is, we're going to substitute the x coordinate into here. And then not to forget, the question already gave us the gradient of the curve value is -1. So we're going to substitute those value as well. So h minus 2k divided by -1 cube equals to -1 over here. Remember guys, this -1 value is not the y value, is the dy dx value. Okay, let me bring the paper up. Okay, so this -1 value is not the y value, it's the dy dx value. So I repeat again. So from here, you already form your second equation, which is h plus 2k equals to -1. So this will be your second equation. Alright, I'm going to show you the remaining working in the next page. So please hold on for a moment. Alright, once you already get the two equation, you can proceed to solve the simultaneous equation. It's up to you guys if you want to do the substitution method or elimination method. But in this case, I choose to do the elimination method since elimination method is faster compared to the substitution method over here. Okay, in this case, I choose to eliminate the h variable over here. How I eliminate the h variable? What I did is, the equation 1 I plus with equation 2 over here. So that's why I managed to eliminate the h variable. So -h plus with h, you will get 0. So k plus with 2k, you will get 3k. -5 plus with -1, you will get -6. So from here, 3k equals to negative 6. So from here you get your k value is equals to negative 2. Okay, so once you get your k equals to negative 2, you can substitute this value into either one of this equation over here to get back your h value. So when k is equals to 2, I mean negative 2, so from here you get your h plus 2 in a bracket negative 2 equals to negative 1. So in this case, I choose to substitute into the second equation. So from here you get your h value is equals to 3 over here. Okay, we've already find the answer for the question part A. So let us proceed to the question part B now. So for the step 1, what we're going to do, we're going to find the gradient of straight line 6y plus x equals to 1. Okay, proceed to the next step. So to start off, we're going to bring the x from the left hand side to the right hand side, where you get your 6y equals to negative x plus 1. Okay, proceed to the next step. So from here what I did, I divide the whole equation by 6 to form the straight line equation form y equals to mx plus c. So from here you get your y equals to negative 1 over 6x plus 1 over 6. So from here we know that our gradient value is equals to negative 1 over 6. Okay, this is the step 1. Proceed to the next step. So for the next step, what we're going to do is we're going to find the gradient of the tangent. Okay, let us proceed. So since the tangent and the straight line 6y equals to negative x plus 1 are perpendicular, like mentioned in the question, so from here we can use this formula over here. The gradient of the straight line times with the gradient of the tangent equals to negative 1. By the way guys, this knowledge you learn in the coordinate geometry over here guys. So any two perpendicular lines, the gradient respectively, when you times them together, you'll get negative 1. Okay, that formula we're going to apply over here. So gradient of the straight line we've already get here, which is negative 1 over 6. So you substitute in. So negative 1 over 6 times with gradient of the tangent equals to negative 1. So to find the gradient of the tangent, so what we're going to do, negative 1, we're going to divide by negative 1 over 6. And from here, you'll get your gradient of tangent is equals to 6. Okay, we've already get our second step. Let us proceed to the third step. So for the third step, what we're going to do, we're going to find the dy dx of y equals to 2x minus 4 to the power of 3. Okay. So from here we get our dy dx equals to 3 in the bracket 2x minus 4 square times with 2. So this 2 is actually the differentiation inside the bracket over here. So this 2, you already minus the power from over here. So 3 minus 1, you get here 2. So the 3 you times in front, that's how you get here the 3 in front over here. Okay, so 3 times 2, so from here you get 6 in a bracket 2x minus 4 square. So proceed to the next step. So 2x minus 4, so you expand the bracket. So from here you get 4x squared minus 16x plus 6. Okay. Proceed to the next step. So 6 in a bracket 4x squared minus 16x plus 16. We are now comparing with the gradient of the tangent value. Since you have already found just now the gradient of tangent equals to 6, so you are now equating with the gradient of the tangent value. Why guys? We need to find the coordinate value respectively. Okay. So proceed to the next step. So from here, so this 6 you can divide. So from here you get your answer is 1. So you cancel off. So this 6 will automatically become 1 over here. So 4x squared minus 16x plus 16 is equals to 1. Why I cancel off? Because I divide the whole equation equals to 6. So I divide the whole equation by 6. That's how I got this expression over here. Okay, proceed to the next step. So I bring the 1 from the right hand side to the left hand side. So I get 4x squared minus 16x plus 15 equals to 0. Okay. So proceed to solve this quadratic equation through the factorization method. So from here you get your factorization. 2x minus 5 in a bracket 2x minus 3 equals to 0. Alright, I'm going to show you the remaining working in the next paper, so please hold on for a moment. Okay, I rewrite the working over here, 2x minus 5 and in the bracket 2x minus 3 equals to 0. So from here you get your x value equals to 5 over 2 and x value equals to 3 over 2. So you get here two respective x value. So once you get the respective x value, you need to find their separate y values. Okay, so when x equals to 5 over 2, so y equals to 2 in a bracket 5 over 2 close bracket minus with 4. So these 2 and 2 will cancel off. So from here you get answer is 1. So you get your y is equals to 1. So proceed to the next step. So this is the second x value. When x equals to 3 over 2, so from here you get your answer y, 2 in a bracket 3 over 2 close bracket minus with the 4 to the power of 3. So these 2 and 2 will cancel off. So 3 minus 4 you get negative 1. Negative 1 to the power of 3, you get your answer is negative 1. So from here you get your two respective coordinates value, which is 5 over 2 comma 1 and 3 over 2 comma negative 1. So this is your final answer, guys. Okay, let me turn back to the question paper. So for your reference, so please hold on. Alright, that is all for my step-by-step working and solution for this question. Any question or feedback, feel free to put in the comment section below. And before that, please tell me your feedback, guys. How do you find out this question? Is this question easy or difficult? And most important thing, could you manage to solve this question? If you like this video, please give a thumbs up. If you haven't subscribed to the channel, please subscribe to the channel and hit the bell icon for more upcoming mathematics tutorial videos in the future. Alright guys, thank you everyone for your support, and I'll see you in the next video.